Hey everybody, this is my Milwaukee battery charger. My 12-volt lithium-ion battery charger charges the batteries for my cordless drill and my impact driver. They're nice portable small ones. They're only 12 volts, so they're not a whole lot of power, but I use them all the time. I've always liked them. And recently I went to recharge the battery, and lo and behold, the charger is dead. If I put the battery in, normally what happens is the red light comes on to indicate that it's charging, and then it'll go to green when it's fully charged. When I put the battery in now, I get no lights at all. And first I thought, well, maybe I had a battery go bad, because my batteries are the original batteries, and I've had them for a few years now. They're lithium-ion batteries. They're pretty dependable. But it turns out it wasn't the batteries, because I tried the other battery and it does the same exact thing. So something has happened to this charger. I don't know what. I do have a sneaking suspicion that I inadvertently allowed this charger to get wet. So that might be the problem right there. So I figure we'll do a little autopsy. Hopefully maybe even a repair, depending on what we end up finding. So first thing I'm going to do is, if I can find the battery, I'll demonstrate what it's not doing. Alright, so here's the little battery, and plug it in. No lights. So let's open it up. Now the first thing we've got to do is we've got to overcome Milwaukee's insistence on using these security Torx screws. So a normal Torx bit will not work in these. You need what's called a security Torx, which actually has a little hollow. They're actually a hollow shaft. So I've got a little hole in the center of the bit, because there's a pin inside here. So if you try and put a regular Torx bit in that hole, it won't go down in and engage. So you've got to have one of these security Torx bits, which is kind of a pain in the butt, but I guess they really just don't want you working on this yourself. Alright, the first thing I notice right off the bat is that there is a glass fuse. It's what's called a pigtail fuse, because it has little metal leads on it, and it's soldered into the PC board. So just to make it, interesting, if that fuse blows, they're basically forcing you to have to take the board out and unsolder it. You can't just unclip it and clip another fuse in. They save a few pennies there on the parts, I guess. And the other reason is because if this fuse blows, the general thinking is you've got a short inside here and there's something else more serious wrong with it anyways. It's kind of rare for that fuse to go and not have something else going on. But just for due diligence, since this thing is dead, we'll check the fuse. But unfortunately, or fortunately, depending on which way you look at it, the fuse is good. Sadly, this is starting to shape up to look like one of these deals where I'm not going to be able to do anything. There are no visibly burnt parts. There's no visible corrosion. There's nothing to indicate why this isn't working. And this, for being something that does such a simple job of charging batteries, it's actually quite a sophisticated circuit. I was able to measure on these 4 diodes right here, because of their proximity of the direct AC input, and next to these 2 large capacitors right here, indicate to me that this is a bridge rectifier. These 4 diodes are in a bridge array. The fact that there's 2 filter caps here would indicate to me that they're probably getting a positive and a negative DC supply raw off of the AC input. We get 120 volts AC in, and with the capacitors in there, the bridge being fed directly by the AC, we're getting like 168, 170 volts DC. that is more than likely being fed to this semiconductor right here on this heatsink, which is probably a switching transistor, maybe even a MOSFET. The transformer right here is probably a switching transformer. So what we probably have here, this is an opto-isolator. Okay, this little device right here with the 4 pins on it. So what we've got here is we've got a switch mode power supply. It's taking the incoming raw B plus and it's chopping it up at a high frequency to create multiple secondary DC voltages to run various circuits and also do the battery charging. The other circuits are doing a lot of monitoring. We have what looks like a large-scale integration semiconductor right here. This could very well be a small microprocessor or some sort of digital controller. Not going to bother because not going to be able to find a schematic online for this, I doubt. There's one last thing I can try. I do think that all of my problems started with this when this thing got wet. And what I'm wondering about is, you see this yellow goop that's all over the board here? Well, I know that in the past, I've had situations where this yellow goop that they put on the board had become conductive. And what it essentially causes is it causes a high resistance short circuit across critical areas and can cause trouble. So I could try and scrape some of that off to see if that makes a difference. But I mean, that's a real shot in the dark. But at this point, it might be worth it just for the heck of it before I totally give up on this thing. All right, I cleaned up a lot of that crap that was on the board. There's a little bit in this section here around this capacitor and a little bit around here. Mainly it was concentrated right in this area where these wires are and all of these outputs are really. So got all those cleared out. Let's see if that did anything for us. Still dead as a doornail. Well, that's interesting. This is actually showing that it's outputting 11.4 volts. It's probably reading the battery voltage. Nothing happened. So I poked around online to see whether or not anybody had actually successfully repaired one of these models. The only thing I found was I did find somebody who suggested to somebody else who had a problem with a similar Milwaukee battery charger to change this semiconductor, this TOP semiconductor in the primary side. Now that I look at it more closely, I realize there's 4 leads coming out of the bottom of this, and it might even be using the tab as a 5th lead, so this might actually be a 5-pin semiconductor. This may very well be a voltage regulator. Don't know. Don't know, don't care. The reason why I don't care, and the reason why I'm not just going to order one of these and go through the trouble of changing it out, is because... So here's why it doesn't even make sense to bother trying to fix this this charger. I'm going to cut the cord off of it and throw the cord in the pile of scrap wire. Here on eBay, these are previous auctions. This is new other, so I don't know if it's new old stock or what the story is on them, but I mean, look at this. $5.50 for that charger, free shipping. I mean, that's I don't even know how anybody's making money on that. $7.50, $10. I mean, there's plenty of used chargers on there for short money. Some of these actually are new other, so I have to see what the description says. Point is, I can get a working charger. I bet you if I buy that semiconductor alone and pay the shipping on it, it's going to probably be somewhere around like $8 or $10, and then I've still got to unsolder it, solder the new one in, and it may not even work. So I guess that's going to conclude. This is going to be a real short video. Oh boy. Oh well. Well, I guess this is going to be a really short video, huh? All right, my apologies to anybody who came here looking for an answer. Well, I guess I did give you an answer. The answer is don't bother even trying to fix it. Throw it away. Well, so here's the one I ended up ordering off of eBay, and I ended up putting in a best offer that was accepted of $13, and this came with free shipping. So, and the guy sent it, whoever this sold this to me, sent it priority mail, which was nice. So I gotta believe it probably cost $6 or $7 for him to ship it, or her. And so I mean, in the end, I ended up paying like probably $6 for this thing. They did list it as, I believe, new other. Yeah, new other, see details, not in box. Now the interesting thing is, came in, I unpacked it, and it does look like it's in really good shape. There are like very few scuffs or scratches in it. It looks like it may have also been wiped down. But in here, I'm seeing quite a bit more dirt than I would expect to see on a charger that was in fact brand new. Unless this was just left in a dirty area unboxed. The other dead giveaway would be how much I could see for scratches on the contacts. Yeah, when I look at it under magnification, I really don't see many scuff marks on there. Every time the battery is pushed on there and taken off, it makes little scratch marks, and I don't see hardly anything. So my theory is that this was outside of its box, that it is in fact probably new, and it was just left out of its box. They also did a pretty good job of tying that. That looks almost like a factory tie job there on the twisty tie. Of course, anybody could do that. But the cord also does not look like, oh, hold on a second. No, that cord right there on that very end, I don't know if it's focusing or not. I'm not going to sweat it as long as it works. All right, plugged it in the moment of truth. Hey, and that's exactly what should happen. That's going to stay on, and that will turn green when the battery is charged. So I'm happy to report that, well, I almost said the successful repair, but let me put it to you this way. That's why sometimes it's just not even worth bothering to try and repair something. All right, that'll conclude this video.